right, good morning, everyone. Let's preview what's coming up these next few weeks. Okay, so we just took our 5.2, 5.4, 5.5, 5.2 to 5.5 quiz. Now we're moving into differential equations, which you're going to feel like we're just building on top of what we did with the previous section. We're taking the integral still, but now we got to fight battles on both sides of the equation. We got to deal with the x's on the right, but we got to also deal with the y's on the left. And that's just going to feel like the problem is going to feel extended. It's going to feel like we got to do two problems within the same question. So understand that though this is kind of like the most important topic from this unit, in the sense that this is almost guaranteed to show up on the AP exam in more than one form, more likely than not. And so we're going to get a lot of practice with this. I think students tend to dislike this topic more than others. But I think the good thing is that once you get enough practice with this, you'll feel comfortable. And when you get to the AP exam, you feel like if you see it, you know what to do. Like it's very straightforward. Meanwhile, some of the other problems, you kind of have to read it and you got to interpret it, and things can change from how problems are presented from one to the next. But on the free response, if this shows up, I feel like if we do enough of them, we kind of have that pattern. We just have to follow those steps and solve those equations. Tomorrow, we're going to do a little bit from the calculator perspective. This is word problem, but it's the calculus is not as intense. It's just a matter of knowing where the values get plugged in and solving for one variable at a time. Not a lot of calculus here, but we do need to be familiar with this. But the most important topic is what we're going to do today here. Next week, we have a little bit more to do with slope field, and our final set of integral rules is going to be with the inverse trig, antiderivatives. And then more review, and right now I have the test scheduled for Wednesday, but we'll see. Okay, it'll cover over the quiz topic as well as what we're covering now until the end of the unit. So we're just merging these topics together and calling it Chapter 5/6 test. I am working on trying to finishing up your test. It's going a little slow, but I'm hoping that I can make progress with my teacher workday and the President's Day. I can finish all at least your test. I want to get that test grade finished first, so that I can give it back to you, and then you can decide whether you need to do a test recovery. And test recovery is only up to a 79, but still, I need to get it to you in time where you can do the assignment associated with the recovery. So yeah, just to let you know, I'm working on finishing up trying to get your test graded. And then hopefully soon after I can get your quiz graded, so I can get that back to you. You can have that to review. Make sure you understand those topics before we see the test. Let's see. But either way, we should be able to be complete with this second to last unit before March hits. And then when we get to the end of February, beginning of March, we'll have our final unit, Chapter 7, and then we can circle back and begin reviewing, begin our AP review before spring break. Okay, any questions right now? Okay, so let's start our notes for differential equations. So I have this notes page under today's as a file under today's link. But I also just recently, just last night, I created a summary sheet, a summary of steps, and I just try to put everything, all the steps as well as all the suggestions in terms of how to process the steps. So it's quite a lot here, but we're not going to be able to hit, not every problem is going to require us to look at everything, but I think as we do enough of them, I think these are kind of good steps, good reminders. So Just to let you know, this is still a work in progress. I may add some things to it or realize there's a better way to word that. So if you print it out, that's great, but I may kind of tweak it over these next couple of days. Okay. So as I introduce the topic, I'll come back to this summary sheet and kind of highlight the steps. Okay. So we're starting with differential equations. The big idea is this. The big idea is that a differential equation is basically an equation that is sitting at the derivative level. So if you see any sort of a dx or y prime or, right, so anything that is telling you, any notation that's telling you that you're sitting at the derivative level, that means we're looking at a differential equation. And the equation is where we have an equal sign. And all we're doing is we're trying to solve that differential equation. We're trying to get that derivative expression up to the function level. And we've been doing that, right? We've been doing that, taking the antiderivative, but now we just have to transfer this onto an equation format, so we should do it on both sides of the equation. So that's basically it, just taking our derivative level expression up to the function level expression. But there's a variety of different types of problems that we're going to be looking at. So the first thing we need to do is we need to separate the variables, because we are dealing with x's and y's, and we don't want them to be mixed. Okay, we want to treat them separately, so we want to handle the x's on one side, and we got to handle the y's on the other side. So we're going to put the y's and dy's, or our dependent variable, we're going to group those together on the left side of the equation, and then anything associated with x or dx, we're going to put on the right side. That's going to be our independent variable. Okay. So and let me just point out a few things here, some background information as we begin this process here as well. If you see y prime, I know we don't see it in this one, but if you see y prime, we want to put it in a more descriptive form so we can see where the variables are. So if you see y prime, we're going to rewrite as dy dx or dy over dx. Okay. This one we don't have to, but the next one we may have to do that. Now this dy over dx is very descriptive. Okay, can't see it here. This dy dx is very descriptive because not only does it tell us what variables we're dealing with, it also tells us what the dependent variable is and what the independent variable is just based off the location. So whatever's in the numerator of your differential fraction is the dependent variable. And we want to put the dependent variable or anything associated with the dependent variable on the left side of the equation. Whatever's in the denominator, the dx, in this case, is telling us that our x is the independent variable. Whatever's in the denominator of your differential fraction, this dx indicates that our independent variable is x, and we want to have the independent variable on the right side of the equation. Okay. Right now, we're just dealing with x's and y's, but down the road, you may see some free response questions that have time involved. So if you ever see time, just know that if I see time, t or dt, that is your x. Okay, so if you ever see t and dt, just know that, okay, that's my x, that's what's going to go on the right side. And I think what tripped a lot of students up is they see like sometimes strange variables like q or p or z, depending on the equation. But just understand that if you see a strange variable, that's your y. Okay, and that strange variable is always going to be paired with time. Okay, so that's a pattern that we see with these AP exam free response questions. That if it's not in terms of x and y, it's going to be in terms of time and something else. Okay. Now, the first thing that we're going to do is let's cross multiply. I find that to be a nice first step. It makes the equation look a little cleaner. It's not going to guarantee a separation of variables, but having everything in the numerator is nice because if something is out of order, you just have to do one thing, just divide it over to the other side, right? And staring at the denominator, it just makes it more stressful. So let's just bring everything to the numerator level, and then we can have a clearer picture and decide, okay, do I need to move anything after this? So first thing I'm going to do is I'm just going to cross multiply. If I see any fraction, I'm just going to cross multiply. So I'll say y dy is equal to 2x dx. Okay. In this case, do I have full separation?
Yeah.
Yes. Okay. So it's not always going to be as easy as this, but we're starting easy and we're kind of working our way up. But we have full separation, right? Our y and dy's are clearly grouped together. X's and dx are grouped together, and they're in the right spot, right? Y is on the left, x is on the right. This is great. Let me point out some things here as we move into other types of problems. The dy and dx, just understand that those have to be in the numerator, okay? If they're in the numerator and they're on the left side and the right side, you know those are locked in. Those are where they're supposed to be, okay? So if you see dy and dx in the denominator, that means something is not quite right yet. We've got to still do a little bit of cleanup. Okay, so I want to point that out. The second thing I want to point out is that here we have y's and x's in the numerator, but they don't have to be in the numerator. It just depends on whatever the problem sets up to be. Okay, so after you separate your variables, if your x's or your y's end up in the denominator, then that's where they're supposed to be. I think a lot of students are uncomfortable seeing x's and y's in the denominator, and so they move it up to the numerator, and then they start the process. And then what happens is then you're having that variable in the wrong place, and it just throws the entire problem off. So just be aware that if your x's and y's are in the denominator and you did your algebraic steps correctly before that, then that's where it needs to be. Okay, we don't want to just randomly move a variable because then we're changing the problem. Okay, so, but this is the easier one. X's and y's are separated. Everything's in the numerator. This will be one of the easier ones here. So now that we have everything separated and everything ready to go, we're ready to take our antiderivative. So now we're going to take the integral of both sides. Okay, so get your integral notation to show up. But now we got to deal with not only the right side, but also the left side as well. That just adds to the length and the complexity of our process. Okay, let's start with the easier side first. Integral of 2x dx. What can I apply there? No, that's just power rule, right? So what does that give me?
2x squared over 2.
Good, right. So we make our degree rise by 1. Let's see, where's my sheet? Okay, we make our degree rise by 1. So it becomes 2x squared over 2. And you said plus c, that's good. All right, so we recognize that, right? We've been doing that ever since we got into it in chapter 4. Okay, so then let's do the left side as well. What do you think? What can we do with y?
Would it also be power rule?
Yep, also power rule, but it just feels a little bit different because we're not used to doing things in terms of y. But treat y like you do x's, and what does this become? Yeah, y squared over 2, 1/2 y squared. Good. Technically, it also produces a plus c, but we talked about how we're just going to put all this constants together and just call it, just name it once and just have it on the right side. Okay, any questions so far? We've basically solved the equation. We're done with the calculus step. Your other, depending on the directions of the problems, we may have to solve for c. We may have to get a particular solution. We may have to solve for y. But getting to this point is kind of a big deal on the AP exam. If you can separate the variables, if you can take the integral of both sides, granted, you're going to have problems that are more complicated than this. There may be a lot of other messiness that can come after it in terms of solving, but if you can get to this point, you've earned the majority of the points that it can offer. So, this is going to be our focus. If we can get to this point, the rest is great, but this is what I'm after. This is what we're after here. Getting to this point. Okay, the rest is a little bit of cleanup. there's still complexity involved, but at least we have the most important steps down. Now, I'm not going to get this general equation all the way down to y, but I do want to show that we can do a little bit of cleanup. We're just going to practice a little bit with the cleanup. I'm going to get that 2 to be resolved. Ultimately, I want to, as we begin to see more problems, we're going to see that we're just trying to get that left side cleaned up. So whatever is there, we want to try to move it to the other side. So here I can see that I can move that 2. So if I multiply everything through by 2, I can distribute that 2 through, and I can get the denominator to go away, basically. Okay, I really don't care what happens on the right side. The important thing is that left side is cleaned up. Now, you can think of it as multiplying a 2 through and calling it 2c, but what do you know about 2c? Still a constant, right? So let's just call it c. Okay, it's not wrong if you do this, but a cleaner version is just calling it just c. Okay. Future questions, we're going to go further. We're going to take the square root. We're going to solve for y, but for now, let's just call this our temporary general solution. And we call it a general solution because we don't have a specific c value. But if the problem is asking you for a particular solution, they'll have to provide you some additional information. They have to tell you an ordered pair that you can plug in and solve for c, which we'll do a little bit later. But right now, we'll stop here for this problem. We'll call this a general solution, even though technically we could go a little further and solve for y, but for now, let's just leave it at this point. Any questions? We're just going to build on this knowledge with future problems. Good? All right, number 2. dy dx. So I say dy dx, which is good. I don't have to rewrite any y prime. There's no y prime showing up yet. So I know I'm dealing with x's and y's. I know I want the y's on the left. I want my x's on the right. But first things first, I want to get my fraction resolved. So I figured if I just cross multiply, or if you just want to multiply the right side by dx, that's fine. But I'm always just thinking in terms of, all right, if I can get a fraction equal to a fraction, I can just cross multiply and I can quickly eliminate having to look at a denominator before I separate the variables. So if I cross multiply here, I get 1 times dy is equal to x 1 plus y dx. Okay, any questions so far? So I've moved all my denominator to the numerator, which is, I like having it in this form. But do I have full separation of variables? Not yet, but it should be an easy fix, right? What's out of place? Yeah, and we can just do what? Divide over, okay, divide it over. Yeah, that's why I like everything in the numerator, because once everything's in the numerator, and if something needs to swap, even if both sides have to swap, you just make them go to the denominator of the other side. So that's going to leave us with integral of dy over 1 plus y is equal to integral of x dx. This form is fine, but if you feel more comfortable pushing that dy out in front of the fraction, you can do that as well if you just feel like that looks more familiar to you. Okay. Now do we have full separation of variables? Okay, dy, dx are sitting in the numerator. That's good. We have y. It just happens to end in the denominator, but it's okay. We can move forward from here. Okay, good so far? All right, let me backtrack for a moment here, and I want to talk about this parentheses here. Just a general note, if they give you a set of parentheses in the differential equation, they are there to help you. Okay, so don't expand the parentheses, not until you separate the variables. So the parentheses are there to kind of help you keep what needs to stay together. So yeah, so before you separate the variables, make sure you just hold on to those parentheses. If you distribute, then you lose what needs to stay together. Now, if after we separate the variables, and if there is still parentheses, and you realize that you have to resolve it to apply an integral rule, then you can expand it. But at the beginning, those parentheses are there to help you, so leave those alone. All right, so we are ready. We have separation of variables. We're ready to apply integral rule on both sides. Let's do the easy side first. Integral of x becomes x squared over 2 plus c. Okay. Can I do power rule on the left side? Yeah, that 1 plus y, right? As soon as we see 2 or more terms in the denominator, add it or subtract it, we know we can't just expand. We got to rely on u substitution. So what's our u value? Yeah, so we know that this is one of the easier natural log problems. So if you want to jump directly from this to the natural log integral, that's fine. But if you want to still take the time to write everything out, that's fine as well. I'll show that work in case you need to see it. So u is 1 plus y, du over dy equals 1. Get everything cleaned up. This matches nicely with our natural log rule. So we apply the rule and then replace the u back in terms of y. And now we've done the majority of the problem. Getting to this point is right. We're like 70–80% there, because you separate the variables. You basically have a version of the solution. It's not cleaned up the way that the problem is asking for, but at least you have some version of the problem. You're done with the calculus. We have to just rearrange it. All right, any questions so far? Are we okay? Okay. We separated the variables, we took the antiderivative, and now the problem number 2 is asking for, when it says solve, we're going to just solve for y, okay? We're going to solve for y. So there's still some complexity involved here. We want to get to that y, but there is some things that it's stuck under. We want to resolve that natural log. Okay, so now we're in our cleanup process here. What can I do to get rid of that natural log? Well, the natural log is not outside the function, so this 1 plus y is inside the natural log. We're not going to be able to divide it out, but maybe we can.
Like you can set it to the e.
Yeah, we can pair it with the inverse function, right? We know that natural log and e have that inverse relationship. We can use one to cancel the other out. So the way we're going to do that is we're going to raise both sides base e. We're going to exponentiate both sides. Both sides of the equation is now sitting in the exponent, because we know that we're trying to get that e and natural log relationship to occur, so we can get that cleaned up. Okay. All right, so this cleans up to be just what? The left side. With the absolute value. Okay, absolute value. We still haven't resolved it. We will resolve it, but not yet. All right, the right side. It's a very specific way we're going to clean this up. Okay, so let me talk about something that we're going to use. We have something called this is the property for exponential expressions. So if something is in the form of a to the m plus n, if I have 2 terms added together in the exponent with the same base, I can separate it into the product of 2 bases. I can think of it, this is going to be the same thing as a to the m times a to the n. So using this property, can you adapt that for this particular problem? Okay. E to the Mm-hmm. And what operation in between? Times. Okay. So that's something we gotta be very aware of. This plus from the exponent does not turn into a plus once we bring it down. Once it comes down, it's going to become a multiplication. So that's a big adjustment that I keep seeing mistakes on a test. You know, so it's understandable, but I just want to point out that's a common thing that a lot of students do. Okay, so it doesn't feel like we're making much progress, but there's actually something that we can do here. There's something about this that we can do.
Turn it into a constant.
Good. So E is a number, right? 2.7. If you take a number and if you raise it to a constant, that is still a number. So the nice thing about this is we can just replace that whole mess and just call it times C. But now it's not plus C anymore. It's now multiplied by C. Okay. Any questions with that? Now, typically, what we like to do is, if we see a constant being multiplied with an expression, we like to put it in front as a coefficient. So I'm going to put that in front of the E. All right, a lot of things here, but as long as you can stay with me and follow each step, that's all I care about right now. We can worry about getting to all the steps when we get through all the practice. But right now, I just want you to ask me questions if something doesn't make sense from the previous step. Okay, are we good here? So we're getting there, right? That natural log has been resolved. There's still this absolute value, and then we can get to that y. So we're going to resolve the absolute value. The way we're going to do it is we're going to drop it. But if we drop it, we can't just drop it without making some adjustments. So when we drop the absolute value, we have to understand that this is representative of plus or minus on the other side. So we're going to say 1 plus y. We're going to make the adjustment and call it plus or minus ce to the x squared over 2. Because the absolute value can represent both a positive expression and a negative expression, right? Because of it's going to allow that adjustment inside the absolute value. But now we drop it, and same thing as having that plus or minus. Now, what can we do with plus or minus c? Just make it c as well. So c is a constant. It can represent positive and negative. So that's the nice thing about C. It can just absorb all these messiness that we have in our problem here. So I'm just going to make it 1 plus y is equal to plus or minus C, but we know C is just representative of all the constants, positive or negative. And now we're one step away. Just have to subtract 1 on both sides. So this is a general solution because the problem did not provide us an ordered pair for us to solve for C. We're going to see that soon, but right now, the best we can do is produce this general solution. Yes?
So assuming the negative 1 doesn't get absorbed to C.
That's right. The negative 1 does not get absorbed to the C because C is being multiplied. Now, if it was plus C, then we can have that negative 1 go into it. But yeah, good question. This negative 1 is not going to be able to combine with the C, so because it's being multiplied. So yeah, good question. All right, we're getting a lot of practice with this later, hopefully a little bit every day, so we can get really comfortable. Depending on the problem, we're going to have to approach it a little differently. Not everything is going to be involving this, but usually if you see natural log, this is what's going to happen. You're going to get this pattern showing up. Okay, good. Any questions? All right, number 3. Okay, so now we're going to move into something involving a specific solution, a particular solution. So it says find general solution, but let's just focus on getting to the particular solution. All right, so what do you think we can do first? Is there anything that we can do to rewrite the problem, maybe?
Oh, the y prime and right as dy dx.
Yeah, it just makes it easier if we can get those notations showing up. We can kind of see where things are belonging when we have everything, all the variables that we want to show up. Yeah, so we'll rewrite that y prime as dy over dx. Oops, sorry, 3y. All right, so step by step, our initial goal is to separate the variables, right? We want the x's on the right, y's on the left. And over the years, just seeing student work kind of help inform me as to what to expect and maybe some things as some common pitfalls to maybe avoid. This is what I see. I think a lot of students, they want to rush that process and they want to just separate the variables all in one step. I mean, you can do it, but there's a lot of things to keep track of. And so I would say take your time, right? Maybe you need to subtract, then divide, then multiply. Don't try to do it all in one step. If you do it all in one step, you may mess up. And if you are starting at the wrong spot, then chances are you're not going to be able to earn points moving forward because you don't have a starting equation that's correct. So let's take our time, move things one at a time. But down the road, when you're comfortable with all these problems, maybe you can skip some steps and you can do some things in your head. But for now, let's just take our time, one step at a time. So what can we do to maybe begin our process of moving things to the right location? Yeah, that's the first thing I see. Right? Let's just move that 2x and see what happens, and then we can worry about what to do with that mess inside with that 3y and that dy dx. Okay, the next thing I see is, well, what if I just make that into a fraction? Then I can just cross multiply and I can just quickly resolve my denominator that's kind of making it difficult for me to interpret. So cross multiply. Okay, let's see here. Do I have full separation of variables?
Yes.
Yes, okay. Now, this is just a suggestion, is we can move forward, we can take the integral of both sides, but my suggestion is try to keep the left side as bare minimal as possible. Eventually, you want to solve for y, so if we can clean anything up along the way, let's just go ahead and move to the right side. It just makes, when we do anything with the left side, we don't have to worry about 2-3 things at once. So anytime I see something that I can move, I'm just going to move things one at a time, because eventually we're going to get that left side to be in terms of y anyway. So I see that 3. I'm going to just go ahead and move it to the right side, divide both sides by 3. Again, it's not wrong if you didn't do that, but this is just what I see is a good practice to do here. So I've made the left side as bare minimal as possible. All I need is y and dy. If I can move anything else to the right side early, I'm going to go ahead and do that. Okay, so I think we're ready. We're ready to take our antiderivative. So integral notation. Okay, what does y become? Okay, y squared over 2. Right. The right side, nice and easy, power rule. Okay, down the road, we're going to see some problems where it's going to be more involved. Maybe you got to do u substitution on one side or u substitution on both sides, and then you just got to take a breath and just treat each like a separate problem and take your time through it. But right now, we're working our way to that. Negatives cancels out. Twos cancel out. Okay, questions so far? Okay, it's asking for a particular solution. I'm going to resolve this too. So anything that I can do that I see that I can start moving to the right side, just, even if it's a small step, I'm going to go ahead and do it. I'm still not going to touch that y squared just yet, but at least anything that I can move over, I'm just going to take some baby steps to clean up that left side. And then 2 times c is just c, so okay. Now, okay, any questions so far? Okay, our ultimate goal is to solve for y and to find the c value. Okay, but the order that you do them in is kind of up to you, right? Maybe you want to solve for c first and then solve for y, or maybe you want to solve for y first and then after you get your general solution, then plug in and solve for c. But I realized that through the different pattern of problems that we're going to see, I kind of categorize it under 2 options. And sometimes you may have some problems where it really doesn't matter which option that you choose. But I think for these cases, it just makes it for a cleaner process. So again, you don't have to follow these options. It's not wrong if you do it a different order, but as long as you know what the goal is and you can get there, that's what's most important. But I just want to share this as we're working through this problem. So if I see my left side being like y squared or y cubed or y raised to a power, I know that down the road I gotta involve a root somehow, and that root is going to cover over that c, and it just makes it a little bit harder for me to solve for c. So my preference is if I see a square root or root down the road, I'm going to solve for c before it gets to that messiness. So that's my preference. So if I see that y squared or y cubed, I'm going to resolve that c first before it falls under that square root umbrella or under that square root notation. Now, if I see a natural log on the left side, then I want to take advantage of all the things that we saw with the c, right? The c e to the x squared, it just absorbs all that messiness. So for me, I like to wait. If I see natural log, I like to wait until I solve for y before I solve for c. I'm going to take advantage of that c notation, let it absorb all the messiness, solve for y first, and then I have a generally easier equation for me to solve for c. So that's just over time. I kind of saw that pattern, and I figured that maybe that'll be helpful too, in terms of helping you decide which is going to be a little cleaner process, whether to wait to solve for c or do it at the beginning. So in this case, I foresee a square root coming up. I'm going to solve for c before that messiness shows up. So I'm going to solve for c here. And the way we solve for c is we take the order pair that they gave us, 1, -2. So 1 goes in for x, -2 goes in for y, and we're just going to go through the process and solve for c. All right. So -2, I'll put the equation down here again. So -2 goes in for y. Oops. So I get 4 is equal to -2/3 plus c. Add 2/3 to both sides. That's the same thing as 12/3 plus 2/3, which is 14/3. So where I made my substitution is where I'm going to replace my c value. So make sure that when you solve for c that you're not just plugging c into just any random location, right? Replace the c where you started making that substitution with the x and y. So I resolve that c value early so that I don't have to deal with that square root or solving for c once that square root shows up. Okay, question so far? Okay, so now we can move towards solving for y. What can we do? Take the square root. Now what's going to happen when I take the square root of both sides of the equation? Something's going to show up. Not necessarily, depending on the x, so I think we're okay there. But there's something in front we got to keep track of. Yeah, plus or minus, right? So anytime you take the square root of an equation, there's a plus or minus involved. So make sure you include that, plus or minus outside of square root. Now, understand that these are two separate solutions. And we're only going to take one of them. So that's our next decision. Do we keep the positive square root, or do we do the negative square root? And our decision is going to hinge on what the ordered pair tells us. That is how we make our decision. So these are two separate branches of the graph. But we want the branch of the graph that is actually going to hold that ordered pair. Which one do you think is going to be the one that's going to do it? So imagine plugging 1 into both expressions. Which is the one that's going to give you a -2? Okay. Okay, why? That negative, right? Anything under the square root is going to always give you positive. The only time that negative is showing up is because you're actually putting it outside the square root. So that's going to be a quick way for you to tell. You don't have to plug order pairs in to find out which one to choose. Just look at the y value. Whatever the sign of the y value is, it's going to lead you to the correct answer choice. So if your y value is positive, then choose the positive square root. If your y value is negative, then choose the negative square root. Okay. Okay. Not every problem is going to require that decision, because not every problem is going to be a square root, but shows up enough where we can quickly decide without feeling like we're just guessing. Okay, any questions? Okay, we didn't get a chance. Yeah, so I'll finish up with example 4 tomorrow. But right now, if you can follow the steps, that's good. That's all I want. If you can follow the steps, we're going to get a lot of practice with this. But if you can follow steps, that's a big positive. Okay, any questions? All right, thanks everyone. We'll pick this up tomorrow. Have a great day.